Hey, AP Physics, how's it going today? So today's the day I'm at jury duty, so I thought I would just go ahead and talk through some of the stuff in our slideshow and then let you get started with everything. All right. So yeah, as far as today goes, you guys are going to be working on your kinematics practice problems. I'm going to do some review on those questions that we had signed last class, 17 through 22. Then I'm also going to have you guys work on question number 23. It's an extended FRQ. I'll give you some pointers, and hopefully you'll get out to a good place on that one. Next thing is the graphical motion practice problems. Graphical motion practice, I guess is what it's called. But in there, we're going to go ahead and do some of those derivative and integral graphs, and we'll see how we do with those. And then the final thing is a Khan Academy exercise. All of these things are going to be due at 9:27. The reason I put it out 2 classes is because next class is just like a 22-minute class. We're just going to do some fun video analysis kind of stuff. But today, we're going to focus on some practice. So as far as homework goes, all of these are going to be due the following class on 9:27. Again, the one that I'm adding for the FRQ, and this is really the last one, is number 23 for the kinematics practice problems. The graphical motion practice should be due at that point, and also Khan Academy. All right, so remember, with all of your problem solving, you all want to do this today. Get out your equations, have them visible on your table, get out your calculator, have your journal ready, and be ready to solve some problems. Always keep your formulas in front of you when you're doing problem solving, and follow the format for problem solving. And there's some notes here that might help you. And Khan Academy, if you're done with everything at the end of the class, do it in class today. Otherwise, this could turn into homework. Okay, so let's start off by looking at the kinematics practice problems. I want to review questions 17 through 22 with you guys. Okay, so let me jump on the sideboard over here, and I'm going to write and talk at the same time. Okay, so the first question here, number 17, an object is released from rest in a gravitational field on Earth. Air resistance is negligible. How far will it travel during the 4th second? So I was just using the idea of the formula for a distance is equal to VOT plus 1/2 AT squared, where your initial velocity is 0, so I can cross off that part of the equation. So notice it's simplified just into distance equals 1/2 AT squared. So what you want to do is you want to figure out 1/2 AT squared for the 3rd second after 3 seconds. Okay. And then you'll do something similar, 1/2 AT squared for 4 seconds. Okay. And so notice what you're doing here. You're saying this is how far I went after 3, this is how far I went after 4, and just doing the difference between those two right there gives you your final answer right there. So go ahead and show your work on that, but that's how you know you got to the right answer. Okay. Next question says, a ball is tossed vertically upwards with a speed of 5 meters per second. How far does it go? How many seconds does it take to get back to its original position? So this one here, you're just going to use acceleration is equal to change of velocity divided by time. Solve it for time. But don't forget that it's t up plus t down. Okay. And that's how you get to that question there. All right. Next one here says, a tennis ball is released from rest. It falls vertically through a small distance in the air. What is the change in the speed of the ball and the change in the acceleration of the ball as it falls? And you want to notice the actual answer is this one here, but you want to explain. Somewhere in your explanation, talk about the effect of friction as a net force. Okay. How's that net force going to affect the falling? All right. Okay, so moving on. Okay. Let's see, 2021. All right. So for number 20, it says here, a graph shows a variation of speed v of an object with time. The graph shows, which graph shows how the distance s traveled by the object varies with t, and explain. And so this one here, you're just going to notice the curving nature. Okay, so go ahead and just talk it over with your partners. What does that mean when you have a curve on a VT graph? Okay, next one here kind of shows you a picture of a graph going on. You've got a truck moving. It says the graph shows the variation with time of the velocity of the truck of a fixed mass. And so which one do you want to go? You want to notice that there's always a curve here. Notice curve, curve, right? Okay. And so what does a curve mean on a VT graph? What does a slope mean, actually? I should say a slope. A curve is just an extreme slope, but you should notice that right there. So go ahead and talk with your partners. What does that mean? Okay. All right. And let's go to number 22. All right. Okay, so 22 shows a body moves in a straight line. The graph shows the variation of displacement with time. Which graph shows motion with a negative acceleration? Okay, so notice acceleration compared to a dt. If you're looking at a dt graph, acceleration shows a curve. Okay, and then you're going to look at the idea of the concept of negative acceleration, and just notice why that's the right answer. Okay, and that's it. Okay, so just kind of noticing those ones now, and then this is your FRQ. Now this one is using our graphical analysis skills, and you're going to be working on these also as part of the upcoming assignment too, looking at how you translate with derivatives and integrals. Those are fancy ways of saying slopes and areas under the curve. Now this part right here, you got a cart that's on a horizontal track and it's moving from left to right. So you can kind of see how it's moving here. During the time intervals when the cart is accelerating, the acceleration is constant. The acceleration during other time intervals is also constant, but it may be of a different value. Data taken on the motion of the graph, recorded below, fill in the gaps in the data table. So notice right here you've got velocity and time. So this is a graph of velocity with respect to time. And so if you notice that your velocity as a value and your time as a value, you can simply just say at time equals 0, the velocity is -4, and I would just plot that point right there. Okay. Then I would continue on like that. Time equals 1, velocity is -2. Notice here this is 1, -2 is right here. Okay. And I would just start filling this in. All right. Now that's kind of what I'm doing. So once you have graphed all of this data, you're then going to notice that from the 0 line right here, call that 0, you're going to have areas above the line and areas below the line. Areas above or below that red line right there are going to be calculated using area under the curve as displacement. Okay? And then once you have figured out the area for, say, time equals 0 to time equals 1, you can then take your area as an area under the curve and figure out what your displacement is for those time intervals. Okay? So the big key here is once you graph it, I'll just say graph it, and then take your area under the curve as displacement. Okay. All right, so that's going to be your trick on doing this FRQ right here. Okay, take your area under your curve as your displacement. Okay. Now the next thing you're going to do is answer some questions. Okay, which time intervals is the car at rest? We're talking about slopes here. We're talking about areas. What thing would tell you when the car is resting? During which interval is the magnitude of the acceleration of the cart the greatest? Acceleration is like a slope on a VT graph. When is that the greatest? What is the maximum value of that acceleration? Okay, so again, slopes and areas, derivatives and integrals. Using the integrals, find out where the car would be at the end of its run at 10 seconds. Okay, so again, using your displacements, don't forget to go back and fill in this data, but that'll help you with that last question, finding out where the car is at the end. Okay. Now, once you have done that, you have figured out your displacements, you've answered some questions. The last thing is you're going to translate that graph into an acceleration time graph. Now, just so you know, these are looking for slopes on the VT graph, so your accelerations are actually just going to be constant values. They could be positive constant values, negative constant values, or they could be 0. Okay, so you would plot those on your graph right there, and then that's it. You're done. Cool. So that right there is the kinematics practice problems. And once we're finished with that, we'll pretty much be ready to turn it in soon, but we'll talk about that when we get back on the 27th. The next thing to do then is to jump into the graphing motion practice. And I went over this with you in class. But as you work through these problems, so you're going to do these in your journal, and you're going to upload these into Google Classroom by the 27th. You're going to notice on here that you have got 3 different levels, level 1, level 2, and level 3. And as we discussed in class, if you have a slope here, that's going to turn into constant values here. So just translate your slopes to constant values. Here you're going to translate your constant value velocities back into slopes, and you're going to start at these black points here. And then here where you actually have these straight slopes here, you're going to go ahead and translate those into constant values for velocity. But you notice the curving sections, they will actually be slopes. And so you're going to translate those slopes back by connecting dots too. Now, once you've done that, you'll have a series of questions using derivatives, which are basically slopes, and then also integrals, which are basically areas under the curve to figure out things like acceleration and displacement from these velocity time graphs down here. And that's it. You'll do that in your journal. You'll upload that. And you'll be done. Okay, so that's it today. Everybody, you have a great day, and it's a great day to be a Lakewood Tiger. Rawr.